Hello, it's me again. Today we're going to practice simplifying statements using ratio identities in trigonometry. Now, one way to recall the basic ratio of the first three trigonometric function is to remember the acronym SOH. Those are the very first identities that I learned in trigonometry, which was introduced to us by our teacher way back in our high school days, back in the 1980s. Yes, I'm that old. Okay, anyway, SOH is that acronym, and of course, SOH has meaning. So here means sine theta, S stands for sine, is equal to the opposite side of a right triangle divided by the hypotenuse. Okay, Ka here means cosine theta is equal to the adjacent side divided by the hypotenuse of that right triangle. And tangent of an angle is equal to the opposite side divided by the adjacent side of that angle. Okay. But there's one thing I also want to introduce to you, and that's the ratio identity of tangent. We can derive that by using the equations here available. We can say that opposite side is equal to h times sine theta by cross multiplication. Okay, so h times sine theta is equal to the opposite side. A here is equal to h times cosine theta. Okay, h cross multiply cosine theta is equal to a. So using those equations, we say that O is equal to h sine theta, and A is h cosine theta. H cancels out, so we now know that tangent theta is equal to sine theta divided by cosine theta. Okay, so that's one very useful uh, ratio identity that we're going to use in our exercises today. Another is the ratio identity of cosine, no, not cosine, but cotangent theta. Since cotangent is the reciprocal identity of tangent theta, this is equal to, just get the reciprocal of sine over cosine, so that could give us cosine theta, sorry about that, divided by sine theta. You may also check out my other video on reciprocal identities. I will include the link in the description below. Okay, so let's go and try this exercise. Simplify the statement using ratio identities. 2 tangent theta times 3 cosine theta. The first thing you have to do is to understand what does it mean when we say simplify. As much as possible, we want to rewrite the term in the simplest form. Like maybe we can multiply 2 and 3 and make it 6, and tangent theta multiplied by cosine theta, and present it in a way that we only see one trigonometric function. For me, that's the simplest term. That's how we simplify. So in this case, since we know the ratio identity of tangent is sine over cosine, then we can cancel out cosine. So the first thing we have to do is rewrite the tangent function using sine and cosine. And in this case, we can also multiply 2 and 3. So 2 times 3 is 6. Then we're going to rewrite tangent as sine theta divided by cosine theta. And there's only one left here, which is cosine theta. We don't have to write 3 anymore because we already multiplied that by 2. Okay, so that's it. Cosine theta cancels out, so the final answer is 6 sine theta. Okay, let's try another exercise here. Simplify the statement using ratio identities. Okay. Now, just like what we did a while ago, we rewrite cotangent in terms of sine and cosine because we're trying to eliminate, or we're trying to get rid of fractions in this case. Okay, so we say 5 times cotangent theta is cosine theta divided by sine theta. Just copy this, multiply that by 3 cosine theta. Cosine theta cancels out because cosine theta divided by cosine theta is 1. Okay, and the rest we just have to multiply. 5 times 3 is 15, and we have something here in the denominator, which is sine theta. And as I've said a while ago, we try to get rid of radicals, we try to get rid of denominators, we just want to see one-liner type of answer here. So from the previous video we had, like the reciprocal identity, sine theta is equal to 1 over cosecant theta. Okay, that this is its reciprocal identity. Okay, so we can say that cosecant theta is also equal to 1 over sine theta. Okay, now this is 1 over sine theta, and 1 over sine theta is cosecant theta. So our final answer is 15 cosecant theta. Here's another one for you. Simplify the statement using any identities. If you want, you can pause this video and try it on your own. Okay. Now, the first thing I will need to do here in this case is I will distribute cotangent to the terms inside the parentheses. Okay, so this would give us cotangent theta times 1, 3 cosine theta plus cotangent theta distributed here this time times 2 over cotangent theta minus distribute cotangent theta times tangent theta. Okay, cotangent theta is cosine over sine, right? So you can say that this is cosine theta over sine theta times 1 over 3 cosine theta. Next, cotangent theta times 2 over cotangent theta. This cancels out, so what's left here is 2. And cotangent is the reciprocal of tangent, so we can rewrite cotangent theta as 1 over tangent theta times, don't forget to write this, tangent theta. So this also cancels out. So what's left is 1. Okay. Looking at the first term here, we can cancel out cosine theta. So what's left is 1 over 3 sine theta, or 1 over sine is cosecant theta. So what we have here is 1/3, 1 over 3. Okay, so what's left here is cosecant theta over 3. Sorry about that. Okay, I will have to write this clearly. 1/3. Okay, cosecant theta over 3, because there's a, there's a number there below, plus 2 minus 1, which is 1. So I think that would be our, can we further simplify this? Let's see. We have a common denominator, cosecant theta 3 plus 3. Okay, and I guess that's it.